All right, now we're going to work on the homework for 1.6. First question here. For the function f whose graph is given, state the following. The limit as x approaches infinity, negative infinity, 1, and 3. And then write the equations of the asymptotes and both the vertical and the horizontal. So let's take a look at this graph. Make sure we understand where the axes are here. Okay, there is the x and y axes. And the first one says what's happening as x goes to infinity, and that's positive infinity. So imagine we're moving along the graph here. We got an asymptote, we go past the asymptote, we go down another asymptote, come over here, and now x is getting bigger and bigger and bigger and bigger. Looks like as we go out this way, now the graph ends, but it looks like it's kind of flattening out over here. So as we go out to positive infinity, which is over here, our graph is approaching a value of, let's see, this is -1, this would be -2. So it looks like -2. Now as we approach negative infinity, now we're going out the other direction. So we're moving out this way, going out to negative infinity, which is out here. And as we're going, we're kind of flattening out here also. And that has a value up here of +2. That answers the first two parts. Now we want to know what happens as x approaches 1. So here's 1. And as I approach 1 from the left, I'm going up to positive infinity. And as I go from the right, it's also approaching positive infinity. So let's make sure, yeah. So because we're going to infinity from both sides, positive infinity from both sides, the answer here is positive infinity. Now as I look at approaching 3, I have to, let's see, figure out where 3 is. Here's 2, here's 3. So as I'm moving, I'm going down, 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 down forever, and then down, down, down forever. Another asymptote here. Both of them are going to negative infinity. That means since they're both going to the same place, we have negative infinity. Now, the places we have our vertical asymptotes would be this line here and this line here. And the equation of this line is x equals 1. The equation of that line is x equals 3. So x equals 1, x equals 3. Now the horizontal asymptote out this way on the right side is this line. It's a horizontal line. That has the equation y equals -2. And then the other asymptote was this one up here. That has the equation y equals +2. So y equals -2, y equals +2. Next question. Sketch the graph of an example of a function that satisfies all of these conditions, and it's multiple choice. But let me just get to the picture of the answer here. So we'll do these one condition at a time. We want the limit as x approaches 1 to go to negative infinity. So I guess I'll draw my own. Let's say this is 1. I want my graph to go to negative infinity here. So I want an asymptote, both sides going to the same place, like that. Okay, now as I go to infinity, okay, as x goes to infinity, I want my graph to go to infinity. So as I move out the right side here, I want my graph to go up forever. And then as I go to negative infinity, out the left side, I want it to get closer to 0. So what I can do is make sure that as I go out the left side, my graph gets closer and closer to 0, like that. And then as I approach 0 from the right, I want to go up to infinity. So here, here's 0. As I approach it from the right, I want it to go up to infinity. And then as I approach 0 from the left, I want it to go to negative infinity. So I want it to come down like this. And so, I could connect these together now like this. And it would be something like that. That's an example of a function that satisfies all of those. Now let's see how close theirs is. Theirs has the same thing. As I move to the left, I'm approaching 0 forever. As I approach negative infinity, I'm approaching 0. As I approach 0 from the left, I am approaching negative infinity. As I approach 0 from the right, I'm approaching positive infinity. As I approach 2 from the left, 2 from both sides, it goes to negative infinity. And as x goes to infinity, my function goes up and up and up and up to infinity. All right, find the limit. Okay, if the answer does not exist, say it does not exist. So we want to approach negative 9 from the right. So what happens if I plug negative 9 in here? Negative 9 plus 10 is negative 1 over negative 9 plus 9, that gives me 0. So what I have here is a fixed negative number divided by something that's going to 0. Now, what I need to realize is that anytime I have a fixed number over 0, it's either, my answer is going to be either infinity, negative infinity, or does not exist. So all I have to resolve at this point is how I'm approaching 0. So I'm going to take a number line. I'm approaching the value of negative 9, and I am approaching it from the right-hand side. So I'm approaching negative 9. Remember, negative 8 is over here. Negative 10 is over here. So what are some values that I could plug in here? Negative negative 8.999. That would be a number that's approaching negative 9 from the right-hand side. If I try that and I plug into this negative 8.999 and then I add 9, I'm going to get a small, small positive number, which means I am approaching this 0 here from positive numbers. Now the numerator is fixed in its negative number, right, negative 1. It's getting closer to negative 1. So it's a negative number over a very, very small positive number. A negative divided by a positive is negative. We know then that it has to go to negative infinity. So our answer should be negative infinity. Oh, we can't check it here. I have to actually go here. Make sure they give you the same explanation. See, the book does it a very different way, I think, in their explanation, so hopefully mine makes more sense. Oh, you know what? Was it plus? Hold on a second. Let me go back to that real quick. Plus positive number, plugged in negative 9. Oh, duh. Sorry about that. Negative 9 here plus 10 is 1. I have no idea why I did that. Spurs game last night. Great game. 1, this should be a fixed positive number, so just strike all that. This should be positive. I need to wake up. Because we have positive over positive is a positive number, so positive infinity instead of negative. Glad I checked. Okay, next one. Find the limit if it exists. So what's happening here, x is going to infinity. 9 times infinity is infinity. Minus 7 is still infinite. So we have infinity over here. On the bottom, we have, again, infinity. So anytime we have infinity over infinity, we need to try and resolve this somehow by doing some algebra. So it's just like when we get 0 over 0, we have to try something. So you cannot say your answer is infinity, okay? And you can't say your answer is 1. Infinity divided by infinity is not 1. So let's do some work. The trick here is to try and use the fact that anytime you have a constant over something that goes to infinity, that will always go to 0 when you take the limit. So what I'm going to try and do is divide through on top and bottom by something that's going to create this situation. So I'm going to take my 9x minus 7. I'm going to take my 2x plus 7. I'm going to come in here, and I'm going to multiply the top by 1 over x and the bottom by 1 over x. In other words, I'm dividing the top and bottom by x. So distribute a 1 over x through, distribute a 1 over x through, and you get limit. X approaches infinity. Try and go with a smaller pen. See, 1 over x times 9x, the x's cancel, we get 9. Distribute through, we get 7 over x. And then on the bottom, 1 over x times 2x, the x's cancel, we get 2, and then plus 7 over x. And now let x go to infinity. Okay, let x go to infinity, which means that becomes infinite, that becomes infinite, which means in both of those cases, both of these, we have 7 over something going to infinity. That's a constant over infinity. That goes to 0. So these two terms are going to vanish, and all we have after we apply that limit is the 9 in front divided by the 2. So the answer should be 9 halves. I don't need to check that. Okay, what about this one? Find the limit as x goes to infinity of this expression. So we have infinity in here squared, that's infinity, plus infinity. So we have square root of infinity, which is still infinity. And then we have minus 9 times infinity is infinity. So we have infinity minus infinity. This again is what we call an indeterminate form. Infinity minus infinity is not 0. Okay, it is something, but we don't know what it is. So we have to do some algebra. So here I go with some algebra on this. I'm going to limit. Anytime we see those square roots like that, multiple terms, we're going to be thinking conjugate. So I'm going to take, there's my original limit, and I'm going to come in here and I'm going to multiply it by its conjugate, which is the same thing with a plus between them instead. And if I multiply by the conjugate, I must divide by the conjugate also. So I'm going to put my conjugate down here. Now, what happens when we FOIL out the top? So multiply that times that. And the roots go away, so I'm left with 81x squared plus x. We know the middle terms, this one and this one, will cancel. The last term I'll have is a negative 81x squared. And then that's all over this conjugate-y thing. Conjugate-y? That doesn't make any sense. This conjugate thing. And at this point, this 81x squared and this 81x squared cancel, which leaves me with this limit, x over square root 81x squared plus x, and then plus 9x. Okay, we are still stuck at this point because if we let x go to infinity, the top goes to infinity. The bottom goes to infinity here plus infinity, which is infinity. So we still have infinity over infinity. So that's still an issue, but we're closer because we've gotten it from being this to this. All right, so how will we deal with this? This is, again, a tricky part of this. What I need to do is try and use that property right up here to make some of this junk go away. So what I'd like to do is I'd like to make this x right here go away. So I'm going to divide through by x. So I'm going to come in here with, better use a different color, a 1 over x on the top and a 1 over x on the bottom, and I will have to distribute that through. This only has one term. I don't really need the parentheses there. And I think because of room, I'm going to erase this up here, and then I'm going to work back up here. Okay, so when I distribute through here, I get a 1. So I have limit x goes to infinity. I have a 1 on top. And then on the bottom, I have to distribute this to this. Now, I've talked about this in my videos. When you force something into a square root, it gets squared. So that 1 over x is going to be a 1 over x squared when it goes under the root. So under that root, I have a 1 over x squared that multiplies times both of these. When you multiply 1 over x squared times 81x squared, the x squareds cancel, which leaves me with 81. When I multiply x by 1 over x squared, one of the x's cancels, but I still have an x on the bottom. And now you have to multiply that 1 over x times 9x. The x's cancel, you just get a 9. And now check out what happens when you let x go to infinity. This one is a constant over x. X goes to infinity. This will vanish. And so what you're left with, I'm actually applying the limit now, so I'm going to not write it anymore. 1 over square root of 81. This is going to 0, so square root of 81 is 9. Right? That's all going to be a 9. 9 plus 9, 18. So you get 1/18. All right. Okay, find the limit. Let u and v represent arbitrary real numbers. If an answer does not exist, enter DNE. So they're just telling you that these two numbers are real numbers, right? And it wants you to find the limit. So if I let x go to infinity now, I get infinity here, right? Because that's just a number times infinity, minus another infinity here. So let's see, I think I might bring up the solution for this just because of the work here. It's going to be very similar to what we just did on this one. Let's see the solution here. Okay, so we start out here. Here's what we started with. We know that's infinity minus infinity. We come in because we see square roots, we do conjugate. Conjugate on top, conjugate on bottom. When we multiply here and here, we get the roots to go away, which gives us this. And then the middle terms cancel, so now we just have this times this. The root will go away because those are identical, but it's going to be negative because it's a negative times a positive. So we get minus whatever was underneath the root. When we distribute the negative through here, right, and get rid of the parentheses here, our x squareds are going to cancel, and we'll be left with ux minus vx. All right, so ux minus vx. And then on the bottom, we just have the conjugate. Now, here's the step they don't show, and I can't write on top of this right now, but they come in with the 1 over x on top and bottom here. And then when they do that, they push it through. I think maybe I'll take it from that step. We have ux minus vx over that conjugate. Let me see. We had limit, x goes to infinity. We had ux minus vx all over the conjugate. The conjugate was square root x squared plus ux plus square root x squared plus vx. So coming in here now with that 1 over x on top and the 1 over x on bottom. On the top, all you're left with when you distribute through is the u minus v. On the bottom, remember it's going to go here and here. When it goes in, it gets squared. It becomes a 1 over x squared. And then what will happen is when it hits this, it'll just become a square root of 1. When it hits this, we'll have plus u over x because one of the x's cancels. Plus, again, when we go into this root, it gets squared. So when it hits this, it just becomes a 1. And then again, one of the x's cancels, so you get v over x. Now when we let x go to infinity, this is a constant over something going to infinity. That's going to vanish, go to 0. That's going to go to 0. So what we're left with is the u minus v on top. No more limit, right, because I let x go to infinity. On the bottom, square root of 1 plus square root of 1. That's 1 plus 1, that's 2. So u minus v over 2. Let's see, is that what we had? Yep, u minus v over 2. All right, what about this limit? Find the limit. X goes to infinity, cosine x. All right, this one's pretty straightforward. Cosine looks like this. And as we go out to infinity, our graph's going up and down, oscillating. It's never approaching a specific value. And since it oscillates and does not go to a specific value, the answer is does not exist. All right, how about this one? Limit x goes to negative infinity of x squared plus x cubed. All right, this one's a little tricky. If we plug in negative infinity here and square, so a negative number, really big negative number squared, it's still positive, so we get positive infinity. And then if we plug a negative number and cube it, it's going to be negative, and it's going to get bigger and bigger and bigger, so it's going to be a negative number really big, so minus infinity. Infinity minus infinity is something we don't know, so I need to do something here. The key here is that that's a negative infinity, not positive infinity. So when you plug it in here, it stays negative. When you plug it in here, it becomes positive. All right, so here's a nice little trick. Limit x goes to negative infinity. All I'm going to do is look at these two terms. Notice they both have an x squared in them, and I'm going to pull out an x squared. And I'm going to be left with 1 plus x. And now, when I let x go to negative infinity squared is infinity, but now I have times over here. 1 plus negative infinity is negative infinity. And a very, very big positive number times a very, very big negative number is a very, very big negative number. Opposite signs, right? So I get negative infinity, and that should be my answer. So what I've done is I've turned this I've turned subtraction. What I meant to say is I turned subtraction into multiplication, and that's a totally different scenario. So we can get a pretty immediate result from that. Okay, find a formula for a function f that satisfies the following conditions. So we need the limit as x goes to infinity, both infinity and negative infinity, to go to 0. Maybe I'll draw a little picture of what's happening here. So I know that as I go out to the right, it's headed to 0. When I go out to the left, it's headed to 0. I need, as I go to 0, I need to go to negative infinity. And notice it says 0, and it doesn't say which side, so that means both sides. So I need to go like this. I need f of 6 to be 0. So at 6, I need it to be 0. And I need, as I approach 8, to go 8 from the left, it goes to positive infinity. I'm going to have to move this a little bit. As I approach 8 from the left, it goes to positive infinity like that. And 8 from the right, it goes to negative infinity like this. Okay, so that's basically what's happening. I have asymptote here. I have asymptote here. And now what's kind of weird is the way I have this drawn on the right side. I needed to, as I go out to infinity, to go to 0. I could just come in like this instead and not put that one up there like that. And same thing over here. I could make this one go like this. That would still go to 0. So I kind of put that together after the fact. And then I can make that triangle something like that. So this is a rational function. Now, here's how I can create it using just my knowledge of asymptotes and x-intercepts. If I want this x-intercept to happen at 6, I need x minus 6 to be in the numerator, so that if I plug in 6, I get 0, which is going to give me this. If I want a vertical asymptote at 8, or let's start at 0. If I want this one right here, and I want them both to go down to negative infinity, then what I can do is I can plug in at 0. So in other words, when I plug in x equals 0, I need to be undefined. So if I plug in 0, right? If I plug in 0 right now, it's going to give me an undefined here. So I should put an x here. Now, the fact that they both go to infinity, negative infinity, means that I need, well, I'll have to kind of resolve this. Let me put the other pieces together and we'll get all the signs correct. I also need another asymptote at negative, or at positive 8, so I need minus 8 down here. Okay, let's just verify again what this is doing. This gives me this, right? This gives me this, and this gives me that asymptote. Now I need to make sure that I get my horizontals, my horizontal that goes to 0. Well, in order for it to go to 0, as I go out to the left and right, I just need the degree of the bottom to be bigger than the degree of the top. Okay, that means the bottom will get bigger faster than the top will. Well, the degree of the top is 1, because that's linear, and then down here, if I distribute through, that's quadratic. So I already have that. So I know that it will go to 0 as x goes to infinity. Let's just check now that when I approach 0 from the left and from the right, that it's going to go to negative infinity. So let me check. Limit as x approaches 0 of x minus 6 over x times x minus 8. So if I just let x go to 0 here, I get negative 6 on top. X goes to 0 there. That's going to approach 0. And then over here I get negative 8. Now, the problem that I'm having here is that I know that I have a fixed, when I put these two together, that's a positive number. So I have a fixed positive number divided by something headed toward 0. Well, if I come in from the left side of 0, that'll be a negative number. If I come in from the right side of 0, that'll be a positive number. And that is not good, because that would mean the limit doesn't exist, and I need it to exist. So what I'm going to do is I'm going to adjust something here. It's going to make it pretty nice. I'll do it in a different color so you can see it. I'm going to adjust this to make it squared. Okay, so I squared that right there. And now I'm also going to make it negative. Okay, so I'm adjusting my function right here, negative and x squared. The squared part of it is going to make sure that whether or not I come in from this side or this side, I square it. It's getting small. I'm going to square it, which makes it positive, and then the negative out here is going to make it negative. So let me run through this logic again, make sure you understand it. Okay, if I let x go to 0 now, on top we get negative 6. On the bottom, 0 squared is 0, and then negative, so we just get basically negative 1 times 0. And then over here, 0 minus 8 is negative 8 times negative 8. Now, check out what happens. If I look at these numbers here, this, and this, those together all create a negative number. So what I'm getting now is a negative fixed number, a fixed negative number over something that is headed towards 0, right? This was headed to 0, but it's always positive because of the squaring. Regardless of which side I come in from, if I come from the right or the left, no matter what that number is, once it goes in here, it gets squared and becomes positive. So this will give me negative infinity regardless of either side. And then you now have to check to make sure that this asymptote is correct. So let's just check that one. What is the limit as x approaches 8? Approaches 8. And I'm going to approach it. Let's look at it from the left. We need from the left of this function, which I said is x minus 6 over negative x squared times x minus 8. I need that to be equal to infinity as I come in from the left. So what happens if I approach 8? Well, 8 minus 6 is 2. Okay, 8 squared is 64, but it's negative 64. And if I put 8 in here, I get a 0. Question is it positive or negative? Well, here's 8. I'm coming in from the left, so something like 7.99. If I plug that in here, 7.99 minus 8 is a negative number, so I know that this is approaching 0, negative values. So what I have here is a fixed negative number over something that's approaching 0 through negatives, and negative over negative would be positive. So that gives me positive infinity. You can check the other side yourself, that if you come in from the right side, you get basically the opposite and you get negative infinity, which would make that happen. That's a pretty strange problem. I don't see myself giving you something like that on a test, but it's a good exercise in understanding how to create functions from properties, that you want the graph to satisfy. Okay, number 10. All right, so a tank contains 9,000 liters of pure water. Brine that contains 40 grams of salt per liter is pumped into the tank at a rate of 25 liters per minute. Shows the concentration of salt 10 minutes later in grams per liter is this. So this is a word problem, and I want you to actually work through this. I don't want to guide you too much through this. I want to see if you can extrapolate what we've done up to this point, if you can associate it with a word problem. If you need help on it, you'll have to reach out to me for help. All right.